In this lecture, we will have a look at the power rules, or the rules for exponentiation. Throughout this lecture, all bases are real numbers and all exponents are natural numbers, and our symbols a, b, n, and m are such that all powers are valid. The first rule deals with the product of two powers with the same base. With the product of two powers with the same base, I can simply add the exponents. The reason for this rule is not hard to see. For example, if I have a to the 3 and multiply that by a to the 2, then this is a times a multiplied by a times a, which is equal to a to the 5. This works even if the exponents are negative. For example, a to the 3 multiplied by a to the minus 2. This is by definition a times a multiplied by 1 over a times a. 2 of the a's will cancel and I'm left with a. This is precisely what we get if we add the exponents. We get a to the power 3 minus 2 or a to the power 1, which is a. The next rule deals with a fraction of powers with the same base. In this case, I simply subtract the exponents. Again, not too hard to see why this is true. For example, a to the 3 divided by a squared is the same thing as a times a divided by a times a, which is a. This is precisely what I get from the rule, as a to the 3 minus 2 is a to the 1 or a. Again, this works perfectly fine with negative exponents. For example, a to the 3 divided by a to the minus 2. If I multiply both sides by a squared, then a to the minus 2 multiplied by a squared is a times a divided by a times a, which is 1. Thus, the result is a to the 5, which is what we get from the power rule, as 3 minus negative 2 is 5. The next power rule, I have a power where the base is a power itself. I have a to the n and that whole thing raised to m. The result is that I simply multiply the exponents. Let's check this as well. If I have a to the 3 as my base and my exponent is 2, this is equal to a times a squared, which is a times a times a times a times a times a, or a to the 6. This is precisely what I get from the power rule, as 3 times 2 is 6. In the next rule, we have a power where the base is a product of two numbers. So I have the product of a and b, and that whole thing raised to n. I can write this as a to the n multiplied by b to the n. Let's see why. Let's say that I have a times b raised to 3. By definition, this is a times b times a times b times a times b. Since multiplication is associative and commutative, I can write this as a times a times a times b times b times b, which is a to the 3 times b to the 3. We have a similar rule for exponentiation when the base is a ratio. A divided by b, that whole thing raised to n, is equal to a to the n divided by b to the n. It's also useful to remember that we have no nice formula for a to the n multiplied by b to the m. If you do a product of two powers and neither the base nor the exponent is the same, then you cannot simplify the expression. Also, if the base is a sum, then there is no nice formula for such an expression, with emphasis on nice. There is a formula, sometimes called the binomial theorem, but it's not a trivial formula.